Hey guys, this is Veda here, and today I'm going to talk to you guys and show you guys my smart monitoring project model. And as I said in the last video about soil monitoring and how it helps the farmers, we will make a small project which will show soil readings, which is very helpful because the farmers can now know how much water to add to the soil. Now first we talk about what is Arduino. Arduino is an open source platform used for building electronic projects like this one. Arduino consists of both the physical programmable circuit board, often referred to as a microcontroller, and as a piece of software or IDE, integrated development environment, that runs on your computer, used to write and upload computer code to the physical board. Now we'll talk about one of the main components, the ESP8266. The ESP8266 Wi-Fi module is a self-contained SoC with integrated TCP/IP protocol stack that can give any microcontroller like the Arduino access to your Wi-Fi network. The ESP8266 cable is capable of either hosting an application or offloading all Wi-Fi network functions from the another application processor. Each ESP8266 module comes pre-programmed with an AT command set firmware, meaning you can simply hook this up to your Arduino device and get about as much Wi-Fi ability as a Wi-Fi shield offers. Now we'll talk about how to connect the Arduino to the soil sensor. So let's get into it. Now let's move on to connecting the Arduino to the ESP8266 and the soil sensor. So for this project you need a bunch of items like the Arduino, the ESP8266, the soil sensor, and a bunch of 1-pin connectors. On the ESP8266, connect one of the pin connectors to the TX pin, the top left corner, the ground pin just below the TX pin. For the other two pins, you have to connect two female pin halves to one male pin connector like this. And lastly, you have to connect one pin connector to the RX pin to the bottom right corner. And now for the connections in the Arduino, you have to connect the custom made wire to the 3.3 volt pin on the Arduino. You have to connect the ground wire on the ground pin of the Arduino. You have to connect the TX pin to the 0.3 of the Arduino. And finally the RX pin to the 0.4 of the Arduino. And now for the soil sensor, connect one connector to the VCC pin, another to the ground pin, and finally one to the A0 pin of the soil sensor. And now for connecting that to the Arduino, connect the VCC pin to the 5 volt pin of the Arduino, connect the ground to the other ground on the Arduino, and connect the A0 pin on the A0 pin on the Arduino. And that's how you connect the Arduino and ESP8266 to the soil sensor. This is the Arduino open source platform where you can write your code. So first we'll create a global variable value that will store its data, which will come up on the screen. And then we'll create the void setup method, which is made to set up the inputs and the outputs of the Arduino. This part of the program runs only once when the Arduino program is powered on. Initialize communication between the Arduino and the computer using the serial.begin and a baud rate of 9600. Baud rate is the number of bits transferred between two devices. For example, the Arduino and the computer in this case. Pin mode is how we will try to define the pin of the Arduino to either be input or output. And in this case we are declaring the A0 pin of the Arduino as an input. Use analog read command to read the data from the sensor and store it in the value variable we created at the start. The map command is used to map the raw data received from the sensor to a range of values. So you can use this command to receive values between a certain amount of range. Like in this case, it's 0 to 1023. Then the map sensor data is displayed on the serial monitor using the serial.print command.
And lastly, the delay command is declared to add some delay between each value. And here, for example, we have given a 2000 millisecond delay between each new value.
The Arduino open source platform, we can use it to check the result. So right now the readings are showing 0 because the soil sensor is not in contact with anything. But when you put the soil sensor into a glass of water, see, now it shows readings like 72, 75, etc. That's how the soil sensor works.
That's it, guys. In the next video, I'll show you guys how I integrated the smart pump into the soil monitoring project to make this smart irrigation project. And yeah, I'll see you guys in the next video.